After understanding the basics of the Cobb-Douglas production function, now we will shed some light on the Cobb-Douglas isoquants. So the isoquant requires the output to be fixed at a certain level. Therefore, instead of Q, we will write Q bar that shows the constancy of Q. So on the left hand side now Q appears with a bar on it, whereas the right hand side remains the same. Now since we are considering Q as the fixed part, only V1 and V2 will have the tendency to change. So it is better to write V1 in terms of V2 or V2 in terms of V1, because Q is considered as constant in this case due to the existence of the isoquant that has the same output throughout the isoquant. Now V2 is being extracted here in terms of V1, therefore V2 is appearing on the right hand side. We have shifted the other terms to the denominator of the left hand side. Now it's better to write V2 here instead of right hand side, and beta is gotten rid of simply by raising the power 1 over beta on both sides, or we can shift this power to the other side, making it a reciprocal of what it was, that is beta is converted into 1 over beta. V2 is equal to this is the new form of the function where V2 is expressed in terms of V1. Here there is another thing that we can note, and that is the separation of these two terms, that is term V1 and the other terms, that is Q bar and A. So we have separated these two terms, and now we have gathered the powers, that is minus alpha and 1 over beta. They have been gathered here, and finally we have a more consolidated form of V2 in terms of V1. Another lesson that we can learn from this situation is that when V2 approaches to infinity, the value of V1 will not equate to 0, rather it will approach to 0. It is so because we cannot have one factor of production working alone and producing the output. We require two inputs that have complementation between them in order to produce some output. Labor requires capital and capital requires labor. That is another thing, that the proportion is quite different in different situations. Labor can be less or capital can be less. It can be labor intensive or capital intensive technique of production, but we require both. This is why no matter how much we increase this factor of production, the other factor of production will not reach 0 and or will not become 0. It will reach approximately close to 0. It can be reduced, but it cannot become 0. Now the same holds for the other factor of production. No matter how much we increase this V1, V2 will not be equal to 0. It will still be there, though in very small quantities, and therefore we will have an asymptote to V1 in this case, and asymptote here. There will be an asymptote adjacent to V2, and here there will be an asymptote parallel to V1. So the description is here of this phenomenon that we just understood, the complementarity between labor and capital or any other two factors of production. Now we will calculate the isoquant's slope. We know that the isoquant has capital, the output as a fixed factor, and variable factors will be there, that is the two inputs V1 and V2. And isoquant's slope is basically the rate of change over the isoquant. It means that there will be increase in V2 and there will be a decrease in V1, or vice versa. So it is better to calculate the derivative, which will allow us to get this rate of change that will happen. So the derivative in partial sense will be taken here with respect to V1 of V2, and when we do this simple differentiation process can be done, where this term has been brought out because it doesn't have V1 in it. This term had V1, so we are going to differentiate it, simple power rule is applied, which you can understand by pausing the video. And once you do this, this will be the answer of power rule. And now we focus on these two terms, because the ones that I have underlined, because these terms are basically when written together equal to V2. We remember it from the beginning that these two in the form of a product, they are equal to V2. So we write V2 instead of them and rearrange it a little bit and bring out this term which is not equal to any part of V2. So these will be replaced with V2 still underlined, and before we do that, this -1, the power of V1, it should be brought out, because in the value of V2 we have minus alpha over beta, but we do not have -1. So this V1 raised to the power -1 is separated, and finally we get the actual value of V2, which is substituted here. And now we are going to solve it, consolidate it, and now we have written its consolidated form. V2 over V1 is the final answer of the slope of the isoquant. Now it has its meaning, because it has a negative sign. It shows that there is a negative slope of an isoquant. It has this coefficient, and this is the ratio of the factors, that is factor proportions. Factor proportions is here, that is V2 over V1, and negative sign is already explained. But this term, that is the coefficient, which is constant in nature because alpha and beta both are constants, is a kind of thing which is increasing or decreasing as a coefficient, this value. And this happens when we have an isoquant, a number of them, and if a constant is being multiplied with the factor proportions, it is going to give us something which is going to retain its format. And in other words, it is a homothetic situation of the production function, where the angles will remain the same when we draw some ray through the origin, and that passes through the isoquants. So this angle will remain the same in this case, and hence we can call it that it is a homothetic production function, and the property of homotheticity is proved here. So this is another finding regarding the Cobb-Douglas production function that we have, and this is the diagram that we will have if we have a homothetic production function, in this case, which is Cobb-Douglas production function, that the angles, they are reserved, they are not changing whenever we calculate them with the rays starting from the origin. So this is about the Cobb-Douglas production functions isoquant, and finally it's about slope. In the next video we will develop the product curve, average product curve, and the marginal product curve of the Cobb-Douglas production function. Thank you.